Hi everyone, I'm currently in a Techno Hub which hosts the assembly lines of the Samurai robots as well as the Mac Aspect optical units. The goal of this session is to discuss the latest progress we've done on the Mac Aspect development. So maybe the best way to introduce this session is by explaining the basics 101 of what is an optical unit. So as the majority of you know, the main components of an optical unit consist in three main items. So there's the lighting system, there's the vision module, which could consist in different types of sensors, as well as the ejection nozzle bar. So historically, if we're looking 15-20 years ago, the main purpose of optical units were actually in the extraction and the purification of plastic grades within the material recycling facilities. Nowadays, if we go back 6-7 years ago, we start seeing a request for more automation on the fiber streams, which means that now we're in a position to quality control this fiber by ejecting rigid film, metals, and cardboard OBB-UCC, and or actually shoot positively the fiber to maximize purity of fiber. So a decade ago, Machinex took a really strategic decision in manufacturing and designing its own family of optical unit. The idea behind this was to be as independent as possible from the offer currently on the market. So that concept was driven by the pure desire of becoming a one-stop shop. So a manufacturer that will support the quality of each of its products. So at the time, we could have decided to use more conventional technologies, but instead of doing this, we've decided to go slightly off chart and select a more powerful tool, which was the hyperspectral cameras. So the big difference between hyperspectral cameras and more conventional technologies, which we'll call the multi-point technologies, is the fact that the hyperspectral camera sees the full graph of each and every components that the optical will see. So one of the main benefits of the hyperspectral technology is actually the enhanced recovery and purity rate we get from this machine. But on top of that is actually the flexibility that the technology allows us in terms of new packaging entering the waste streams of our customers. Moreover, another benefit of the technology is actually the fact that we can bring a lab on site, which means that we don't have to take acquisition, send this back to the office, and the information from the office back to the site. We can actually do the acquisition on site, which allows our technician to be much more proactive. So the Machinex optical can come in a variety of options and configurations. The first one is single ejection mode versus a dual ejection mode. So in few words, it means that the optical can actually fire upward or could also fire downward any product's desired. So on top of the different ejection patterns, the technology can come in different widths. So the smallest model that Machinex manufacture is a 1.2 meters wide machine. The widest one that we manufacture is actually a 3.2 meters wide machine. So fun fact, Machinex is the only manufacturer on the market providing an optical as wide, meaning the 3.2 meters wide machine. And that, again, driven by the desire to push as much tonnage as we can in this machine, hence increasing the overall performance of our facilities. So on top of the different configuration that I just previously explained, there's a set of options that can be selected on the machine. So the first option will be the provision of an air tunnel in each fiber application. The goal of this option is actually to match the speed of the air inside the tunnel with the speed of the belt. So matching the air in the tunnel with the speed of the belt prevent the light material to roll on the belt, hence increasing the recovery and the purity expected from the machine. The second option will be the provision of a metal detector. So a metal detector uses inductive sensors to be able to recognize and identify and ultimately eject the metal content of a stream. So the third option you can find on this machine is the provision of a film capture device or a dust collector device, which is installed on top of the ejection hood. The objective of that third option is actually to vacuum the plastic film that will be floating in the ejection hood just fired by the optical unit, or vacuum the dust that will be generated by the optical unit. So what we've learned in the last 10-15 years in integrating this technology is that you may have the best and the widest optical unit. If it's not integrated properly, you will never maximize the efficiency and the purity of this technology. So 2 years ago, we've conducted a survey with 20 of our best power users, and the goal and the objective of that survey was to identify the aspect and the features to be improved on the machine. So what came out loud and clear from that survey is the desire from our customer base to improve the access and the maintenance of our machines. So that request pushed us to go back to the sketch board and design a brand new ejection hood for our optical units that was released in May 2019. Okay, so let's have a look on site at the latest features of the redesigned ejection hood. So the first thing that the technician has to do is to turn the round handle to move the mobile platform to its final position inside the ejection hood. So once this is done, the technician has to rotate the yellow handle, which activates the internal guardrail system. The purpose of this internal guardrail system is to protect the technician from falling inside the ejection hood, but it's also used as a fail-safe system to prevent the technician to open the door without having the guard in place. The new ergonomic design includes a full-size access door for clearance of 81 inches high and 23 inches wide, which ease tremendously the access to the machine. At this stage, the technician can safely enter the machine to get access to the main components which require cleaning and maintenance. In this new ergonomic design, the lighting system and the nozzle ejection bar can rotate to facilitate the cleaning and the maintenance of those components. To access the components located on top of the machine, a ladder has been added as a standard. For the optical unit provided with the air tunnel option, a retractable mechanism is provided to ease the removal of this device. So since its launch, the new ergonomic design has been implemented in many facilities, and the feedback we get from our customers is that it reduced by almost 50% their cleaning and maintenance requirements on all those machines. This really makes this option a commercial no-brainer. As a closure of this segment, let's talk about the future of the Machinex optical units. We are currently working on 3 developments that will improve different aspects of the machine. The first one is the addition of our AI technology within the optical units. That synergy will generate value by enhancing the recovery and the purity we could expect from this technology. The second is the development of a more friendly user HMI, which will increase the adjustment flexibility of our machine by our customers. This will lead to more autonomy to our customers in their operations. And the third development is the elaboration of the Intel dashboard, which consists in a platform which will collect and exchange data within specific piece of equipment to the full system. This data exchange platform, along with the machine interconnectivity, will allow the MRF of the future to become a reality. So as you can realize it now, our teams are extremely committed on the robotic and optical development. Stay tuned for our upcoming developments. Our teams are on it.